We're going to start talking about sequences. This unit is on sequences and series. And a sequence is a list of numbers that follows a pattern. That follows a pattern. And there are two categories of sequences: finite and infinite. Why it's not called finite and infinite or infinite, I don't know. But a finite sequence, any guesses, knowing what you know about the word infinite?
Infinite means that it goes on forever and ever.
So what would finite be?
Maybe it's limited.
It's limited. It does not go on forever. So a finite sequence is a sequence that has an end. So for example, we might have the sequence 0, 2, 4, 6, 8. Does that list of numbers follow a pattern?
Yeah.
Yep, I'm adding 2 every time. Okay. An infinite sequence is a sequence that
has no end.
Has no end. It goes on forever. Now, obviously, I cannot sit and create a pattern and just keep writing forever. I'd sit here until I died. So, how could you show that numbers go on forever?
Right.
That's not actually what we do. We're going to use dot, dot, dot. Yeah, it seems a whole lot more simple, but so 0, 2, 4, 6, 8, dot, dot, dot. That means it goes on forever. Now sometimes, if I go back up here to the finite sequence, sometimes we will see a dot, 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 but then it'll say like 100. And what that means is after 8, that pattern continues until you get to 100. And it still stops at 100. So this, even though you see the dot, dot, dot here, it's still finite. Now in our sequences, each number, hold on, thought I changed that. Okay. Each number in a sequence we call a term. And so this is a term, that's a term, a term, a term, a term. The first term, we label that, or we give it like a special name, which we call A1. So it's a lowercase a with a little tiny 1 down here at the bottom.
Etc.
They actually all say A. So everything is an A. A1, A2, A3, A4. So in general, we will use AN. So if you see AN, that just means a term. You don't know which term. You don't know if it's the 4th one, the 10th one, because it's just an N there. That N represents which term it is. So if you see A11, you're talking about the 11th term. If it's A with a 50, it's talking about the 50th term. So let's see here on this example. What pattern do you notice?
Each number is being added by 4.
Adding 4 each time. Good. So I'm asking you for A1. That means I'm asking you for the first term. What is the first term? 1. The first number in my sequence is 1. What about A4? 13. That's 1, 2, 3, 4. So the fourth term is 13. Now I only have 5 terms listed, but it says ... which means that pattern continues. And we can go up here and continue that. What would come after 17?
21.
We're adding 4. So 21, 25, 29, 33, 37, 41, 45, 49, 53. Okay, that's probably enough. And it keeps going on forever. But I want to know A10, which is the 10th term.
37.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, it is 37. And so then the 13th term, this would be 11, 12, 13, would be 49. Now this is all fine and dandy, but what if I ask for like the 1000th term? You couldn't just keep adding 4 each time. You would make a mistake somewhere. In the future lessons, I'm going to show you how you can take a formula. And it's pretty simple. You can take a formula and find any term you want without having to worry about doing plus 4, plus 4, plus 4, plus 4, plus 4. Okay? But we won't get to that today. Here in questions 1, 2, and 3, I have given you a sequence. And I'm asking you for the next 3 terms.
Negative 32.
Hold on. So I want you to figure out what is happening first.
I'm going to explain, you guys someone else to explain the...
Okay. What's my pattern? Specifically, what about the 2? It's what? Multiplied by 2. So now what's the next one?
Negative 32.
Okay. So we have negative 32. We are multiplying by 2.
Negative 64.
Okay. What else?
Negative 128.
That is correct. Okay. Number 3. Look at those numbers. Don't yell anything out. But look at those numbers and see if you can figure out what the pattern is. Does anybody know?
Adds to, like,
So how do I get from 3 to 6?
you plus 3.
Plus 3, plus 5, plus 7, plus 9. So how would I get to my next term?
Plus 11.
I would have to add 11. And what is 27 plus 11?
38.
Mm-hmm. And then what would I add to get my next term? No, add 13. And what is 38 plus 13? 51. And then what do I have to add? 15. So what is 51 plus 15? 66. Very good. Question number 3. What is my sequence or what is my pattern?
5.
Adding 5 every time.
So 56, and then 61, and then 66.
That is correct.
So, I guess this is pretty easy.
That part is not bad. Yep. Alright, so this back page, we're starting with a formula for an explicit, for a definition, explicit formula. And so I told you just a few minutes ago that I'm going to show you how to come up with a formula. If I give you a sequence and I ask you for this like term that's way out there, how you can do a formula. And so an explicit formula is a formula that helps find any term in a sequence. And so for these examples, I'm not going to require you to come up with the formula yourself. I'm just giving you the formula and showing you how we're going to find a term. So number 4, I've given you a formula. A(n) equals 7 times n plus 3. And I'm asking you to find A3. What letter does that little 3 represent? You don't remember? It does represent the third term, but what little letter did we write by the n? So this means that my n is 3. We're talking about the third term, so n is 3, which means I'm going to plug in a 3 where there's an n. So A3 is 7 times 3 plus 3. Which would be 7 times 6, which is what? 42. So the third term in my list, or in my sequence, is 42. Not too bad. Alright, so number 5, it's asking me to find A1. So my n is what? 1. So I'm looking for the first term. So I'm going to plug in A1 for the n. Where is that n plus 1 located?
In 1.
Where? It's up here at the top. What's that called? Exponent. So when you go to type that in, when you type in 2, make sure you hit this little up arrow button right there to put it in the exponent. You've got to be watching out and paying attention to that.
4.
Yep, we do get 4. So this means that the first term in the sequence is 4. And then number 6, it's asking for A7, which is the 7th term. And so my n is what? 7. So I'm going to put a 7 in the n spot. So A7 is -4 times 7 squared. Which is -196. Are there any questions on that?
Are we done with all this?
Now, your assignment today is going to be a quiz. And one of the questions says, it gives you the formula and it says, find the first 4 terms. Which means you're finding a 1, a 2, a 3, and a 4. So you would have to plug in a 1, plug in a 2, a 3, and a 4. Now we got 3 more questions to do before we get started on the quizzes. Number 7, I give you the formula, and do I give you the n this time? No. I'm asking you to find the n. So it's different. You do not plug in a 20 for the n. Instead, I've given you a n. So we're going to replace the whole a n with 20. And so I write this as 20 equals 2n plus 4. So I know 20 is one of the numbers in the list, and I'm trying to find how far down the list it actually is. So what's my first step in solving this? Subtract 4.
And get 16 out of that.
Okay.
Then we divide 2 from 16, which gives us 8.
Yep.
So n is 8.
N is 8, which tells me that A8 equals 20. The 8th term in the list is a 20. Number 8, I gave you an. So we're going to put a 45 in the an spot, not just for the n. The whole an is 45. We're finding the n. What step do I need to take first? Distribute the 5. So 5 times n is 5n. 5 times negative 3, that would be a minus 15. Then what?
So we change the negative 15.
We're going to add 15.
Then we...
Hold on. Get 60 equals 5n. And now what do I do?
divide.
Divide by 5. And what is 60 divided by 5? 12. So that tells me that my 12th term, or A12, is 45. So the 12th number down the list is a 45. We got one more.
Give me a second, I need to sharpen first.
So we plug in a 26. (26) equals n squared plus 1. What's first?
N squared. No.
Subtract the 1 first. We get 25 equals n squared. Now my goal is to get the n by itself. How do I get rid of that squared? Do not divide.
Multiply.
Nope.
On the square root.
Find the square root. So we're going to take the square root of both sides. And what is the square root of 25? 5 equals n. So that tells me that the fifth term, or A5, is a 26.